Chapter 1. Introduction to Chemistry. What is chemistry? Chemistry is that branch of science which deals with the study of structure, composition and properties of substances and the changes which the substances undergo. It helps us to identify the substances on the basis of their physical properties like color, state, taste, odor, solubility in water, combustibility, etc. It also helps us to know whether a substance dissolves in water or not. Thousands of such studies have been made. As a result, certain properties are found to be related to the internal structure of substance. Knowledge of the relationship between structure and properties can be useful. Different branches of chemistry. Chemistry is such a vast subject that it is not easy to deal with it as a whole. So, on the basis of certain properties of substances and how to deal with them, it is divided into many groups. These groups are called the branches of chemistry. Let's learn their names from the diagram given below. Analytical chemistry. It is the science of obtaining, processing, and communicating information about the composition and structure of matter. In other words, it is the art and science of determining what matter is made of, its percentage composition, and how much of it exists. Biochemistry. It deals with the study of chemical processes of living organisms. Inorganic chemistry. It deals with the study of the synthesis, reactions, structures and properties of compounds of elements in non-living materials like rocks, soil, atmosphere, etc. Organic chemistry. It deals with the study of the structure, properties, composition, reactions and preparation of carbon-containing compounds which are present mainly in living things. Physical chemistry. It is the branch of chemistry that deals with the relations between the physical properties of substances and their chemical composition and transformation. Development of chemistry. Historical perspectives. In many ways, the history of civilization is the history of chemistry, the study of matter and its properties. Humans have always sought to identify, use and change the materials in our environment. Early potters found beautiful glazes to decorate and preserve their wares. Herdsmen, brewers, and vintners used fermentation techniques to make cheese, beer and wine. Housewives leached the lye from wood ash to make soap. Smiths learned to combine copper and tin to make bronze. Crafters learned to make glass, leather workers tan hides. Some of the world's most famous scientists indeed believed that iron could be turned into gold, and several of them tried desperately to make it happen for hundreds of years. Long before much of modern science became known, many early scientists were fascinated by a practice called alchemy. Alchemists believed they could refine base metals such as iron into precious metals such as gold if they could just find the mythical substance they called philosopher's stone. The philosopher's stone they searched for wasn't an actual rock. Instead, it was supposedly a magical wax, liquid or powder that could heal ailments and prolong life, as well as change base metals into precious metals. Alchemists believed everything in the world was made up of four elements: air, earth, fire, and water. For example, sulfur in the Earth's crust burns in with oxygen of air to form new substance, i.e. sulfur dioxide. The iron pillar near the Qutub Minar in New Delhi was made around 400 BC by the iron workers in India. They had developed a process which prevented wrought iron from rusting. It is due to the formation of a thin film of magnetic oxide on the surface. It results in a finishing treatment given to the pillar, painting it with a mixture of different salts, then heating and quenching. Importance of chemistry. The importance of chemistry in daily life presents itself in a number of different and important ways, as the field study is a diverse topic and connected to all other fields. For this reason, it is also known as central science. Now let us discuss the applications and uses of chemistry in some major fields. 1. Agriculture chemistry has helped agriculture in various ways by use of chemical compounds that are as follows. Fertilizers. It is added to the soil to improve the fertility of the soil. Examples: superphosphate, urea, potassium sulfate, NPK fertilizers, etc. Insecticides. It is used for killing insects that infect and destroy crops. Examples: BHC, DDT, nicotine, etc. Fungicides. It is used for destroying fungi, smut, which destroy crops. Examples: copper, sulfate pentahydrate, and hexachlorobenzene. Herbicides. It is used for killing weeds which grow along with the crops. Examples: glyphosate and simazine. Food. Everybody is very familiar with the properties of food such as its flavor, smell, color, preservatives, and processing. Most of the foods are also obtained through various chemical processes, refined oils, butter, cheese, etc. Some methods of food preservatives are canning, freezing, drying, fermenting, pickling, sealing, etc. 3. Medicines. In hospitals, medicines, antiseptics and disinfectants made of chemicals are used for curing patients. For example, medicines like penicillin, tetracycline, ampicillin, paracetamol, aspirin, etc. are used to treat infection. Chemicals are also used to perform various diagnostic tests such as blood tests, urine tests, etc. Chemicals like aspartame is the most successful and also the most widely used artificial sweetener by diabetic patients, which is 100 times as sweet as cane sugar. 4. Cosmetics. Cosmetics are substances or products used to enhance or alter the appearance or fragrance of the body. Example: talcum powder is made from mineral called talc, which is composed of magnesium, silicon, and oxygen. 5. Petroleum. The petroleum industry uses knowledge of chemistry not only for mining and refining of petroleum to produce petrol, but also produces kerosene, wax, and perfumes. 6. Clothing. The knowledge of chemistry has enabled us to make better and more clothing materials, bleached, dyed, and printed natural fibers like cotton, wool, silk, etc. Synthetic fibers like rayon, nylon, decron, orlin, terylene, and flameproof textiles are the gifts of chemistry. 7. Recreation. Cinema films and the items used in fireworks are the products of chemistry. Almost all sports goods are made up of chemical products. Records of popular songs, which are played on cassettes, videotapes, CDs, and other products like table tennis balls, etc., are also gifts of chemistry. 8. Transport. Trains, aeroplanes, ships, jets, buses, cars, scooters are common means of transport. To keep these modes of transport into motion, fuel obtained from organic substance is required, and their bodies are made up of carbon fiber which is as strong as steel. 9. Communication. Synthetic chemicals, metals, plastics, copper wires, silicon chips, enamels, PVC, etc. are used in making telephones, tape recorders, cell phones, computers, laptops, television sets, audio and video equipments are all gifts of chemistry. 10. Industry. The knowledge of chemistry has helped a great deal in the growth and improved efficiency of industrial processes. The following industries have made very fast progress by the knowledge gained through chemical researches: pharmaceutics, soap and detergents, cosmetics, textiles, dyes, paper, rubber, plastics, and petroleum are some of the important chemical substances produced in industry. Some chemists and their discoveries. John Dalton, 1766 to 1844, was a British chemist. He is known for several discoveries. He is best known for the atomic theory of matter. Dalton believed that substances are made up of particles that cannot be divided. He called the particles atoms. He stated that all the atoms of an element are exactly the same. He also suggested that all compounds are made up of atoms that are combined in simple numerical proportions. Joseph Priestley, 1733 to 1804, published his discovery of oxygen in 1775. He called the gas dephlogisticated air. He named it oxygen. He was the first person to dissolve the gas carbon dioxide in water. He also investigated the gases hydrogen chloride, nitric oxide, nitrogen dioxide, nitrous oxide, sulfur oxide, silicon tetrafluoride, nitrogen, and ammonia. Johannes Jacob Berzelius, 1779 to 1848, was one of many medical doctors who became interested in chemistry and contributed greatly to its progress. He developed a system of nomenclature, which is the present system of symbols and formulae. He also discovered several new elements, including selenium, silicon, and thorium. One of his endeavors included a 10-year analysis of some 2,000 simple and compound materials to determine the proportions of their various elements. Antoine Lavoisier, 1743 to 1794, made so many important discoveries and is known as the father of modern chemistry. Lavoisier stated that air contains two gases. He said that one, called oxygen, that helps in combustion and breathing, whereas the other gas does not. He called the second gas azote, lifeless. Now it is called nitrogen. He determined what a chemical reaction really was. His system of naming chemical compounds is still used today. William Ramsay, 1852 to 1916, and Lord Rayleigh, 1842 to 1919, found that the air contains inert gases. William Ramsay won the Nobel Prize for Chemistry in 1904. Inert gases find applications in neon lights, argon bulbs, and in medical fields. Henry Cavendish, 1731 to 1810, discovered hydrogen gas. He called it as inflammable air. He noticed that when metals were dissolved in dilute acids, a colorless gas was evolved. This gas was combustible. He also showed that when the gas was burnt in oxygen, it gives rise to water. Ernest Rutherford, 1871 to 1937, an English physicist, studied the atomic models and, through his experiments, discovered the atomic nucleus. In 1921, he predicted the existence of nucleus. His model of the nuclear atom became the basis of modern concepts of atomic structure. Louis Pasteur, 1822 to 1895, discovered that the microbes cause milk to become sour, the butter to turn rancid, and the wine to turn into vinegar. He developed the process of pasteurization, in which food is preserved by heating it to kill the bacteria in them. He had also developed a vaccine for rabies and anthrax. In 1885, he founded the Pasteur Institute, which is a center for medical research. Henry Moseley, 1887 to 1915, in 1912 arranged the elements in the increasing order of their atomic numbers known as the modern periodic table, and modified the periodic law as the physical and chemical properties of elements are periodic functions of their atomic numbers, the modern periodic law. This classification removed most of the defects of Mendeleev's periodic table. Marie Curie, 1867 to 1934, discovered radium and polonium. Marie Curie received the Nobel Prize in Chemistry in 1911 for her discovery of radium and polonium. She was able to isolate and study the compounds and the nature of radium. Dmitry Mendeleev in 1869 propounded that properties of elements are periodic function of their atomic weights, the periodic law, and arranged the elements in increasing order of their atomic weights in the form of a table known as Mendeleev's periodic table. This classification had many defects and were later modified by Henry Moseley.